Hi, I'm Phan, Chief Architect at SSW. Thanks for tuning in to today's Dev Superpowers. If you haven't seen any Dev Superpowers before, definitely check it out. We cover the latest technologies on the Microsoft stack, and we're not just covering just the theory, we actually go in, show you code and everything. Just Google Dev Superpowers. There's a whole bunch of videos up there already. Today's Dev Superpowers is going to be on C#6 features. So that's a bit about me. So we've come a long way since, well, the start of programming, where, well, basically we're chiseling our code out on stone tablets, like so. So going through the history of the Visual Studio releases, in 2002 we had C#1, 2003 we had a slight bump in C# version where we had the disposable and enumerators. In 2005 we had C#2 with .NET 2. And that was a pretty good release. We had generics, anonymous methods, nullable types. That was quite a big release for C#. In 2007, we had C#3, which gave us the Lambda expressions, which I'm sure everyone loves and uses now. Extension methods, anonymous types, which is our var keyword. 2010, C#4, we've got dynamics, named arguments and optional parameters, some of which were in VB.NET, which C# then got. Then in 2012, C#5 was released with a big focus on asynchronous programming. And that's the current version, well, not the current version, the prior version to what I'm talking about today. So, C#6 features. So the first one I'm going to go into is automatic property initializers. So if you were to declare a class and some properties and you wanted to set a default value, this is how you would currently do it. And let me just jump into Visual Studio and walk through this with you. So I'll start a brand new C# console application. Okay, and I'll just be lazy, and I won't be lazy. I will actually type out the code. Okay, so let's create a new class. Okay, I'm going to call it developer. Make it public. Okay, developer is going to get a property called drinks coffee, which is a Boolean. Okay, and if we were to initialize it, we would do that in the constructor. So drinks coffee equals true. It's a pretty safe bet. Set that to true. Okay, so that's how we would do it in C#5. Now in C#6, we can get rid of all this constructor code. If all we're doing is setting properties, we can just simply move our assignment into our declaration and get rid of our constructor altogether. Okay, so I just saved you, what's that, about 3-4 lines of code. Nice and simple. Okay, so all we do is just set whatever value we want at the end of our property. Okay, it puts the defaults along with the declaration, so if you've got a really big class, you're not searching for, okay, where's the property and then going back to the constructor to see what the initial value is. It's right there along with the declaration. Okay, it cleans up the constructor for actually like more useful things, like any sort of initialization logic that you might have. All right, next up is dictionary initializers. So here's how we would work with a dictionary and start setting some values into a dictionary. So let me quickly do that as well. Actually, I'll just do this in my main. New string. Okay, and if I wanted to set some initial values for it, I would basically be going a, oops, let's make that a Boolean. What do I want? Dev skills. Okay, so C#, yes. VB.NET, yes. Okay, VBA, yes, but I don't want to do it, so I'm going to make that false so that no one gets me to do any VBA code. Okay, so we normally initialize our dictionaries this way, or in C#5, we could actually initialize it using the dictionary initializer, which can do this. Oops. Okay, and if you just copy that through. Okay, so we can do something like that instead of basically repeating this dev skills all the time. Okay, now the problem with this is it doesn't actually look like a dictionary. And I know this is sort of how we would do it with class properties. So in C#6, we've got new syntax where instead of using all these curly brackets, we would use the indexer like that. Okay, and we actually use the square brackets, pretty much like how we'd actually initialize a dictionary. So I think that's much cleaner syntax, and you're not trying to figure out if you've opened and closed enough curly brackets. Okay, so I think that's nice and clear, and it sort of goes back to how you'd originally use a dictionary. Okay, so C#5, basically we use the curly brackets to do the initialization. In C#6, we got square brackets. And I think that is an improvement. Okay, so as I said, there's less curly brackets to try and match, and it's more in tune with how you would use the dictionary. All right, this is probably my favorite feature, string interpolation. So we all know that code like this to basically concatenate a string is bad. So let me just actually do that. Actually, I might be a bit lazy and just copy it out. Oops. Okay, so we're all taught as programmers that this is bad practice, concatenating strings using the plus. We should be either using string format or string builder, or whatever. So really what we've been taught to do, let's just display 2, is use a string format. Okay, and then we've got 0, 1 for last name, comma, 2 for job title, at 3 for company. Oops, first name, last name, job title, company. Okay, we've been taught to do that. Now the problem is sometimes, oh, what if I need to insert something between first name and last name? So we've got a new middle name. I don't have a middle name, but let's just put one in. Okay, so then if we do that, what do? We've already got numbers for our indexes. We can introduce a new one and say that's number 4. Put that at the end. But then when you're reading the parameter list, it sort of is not in the logical order. Okay, so C#6 solves this problem by what's called string interpolation. Okay, so instead of using string format, we've got a special character that we put in front of the string, and then we can use the curly brackets to actually say what we want in our variables. So you can go first name, last name, comma, job title, at company. Okay, so that's nice and neat and reads well. And if you need to introduce a new parameter, boom, still reads great. Okay, so that's probably my favorite feature for C# 6. Okay, so it's better if you use string format, but like I said, there's problems where you have to play around with the parameter numbers and things like that and try to match up which index is which parameter. So C# 6 gives you string interpolation. So all you need to do is put the $ in front of your quotes and then actually put in your variables in the curly brackets instead of the index. Okay, it's much, much cleaner. And you can see exactly what variables are being used. And you can do formatting in line too. So if you've got a date, we can specify the date format right there with the variable. All right, so next up is the null conditional. This is my second favorite one. All right, so if we had a function that took in a parameter, so we've got a generate coffee order, takes in a bunch of coffee instances, favorite coffee instances. Okay, so if we wanted to print out that order, we can use link to select out the name of the coffee and the size and create an array of that and return it. Okay, the problem we have is what happens if our favorite coffee parameter is null? Well, you're going to get a runtime error. Okay, the value cannot be null. So how do you avoid that? Well, you'd have to actually check beforehand whether our parameter is null or not. Okay, so we have to add this extra if statement, okay, before we run our actual logic. Now, let me just copy this. And let's just see how we can go about improving this. Okay, I need to just create my coffee class. Oops. Okay, cool. So I've got my coffee class. So normally to fix this, I'd have to do my null check. If that's the case, return null or do something so that doesn't break. Oops, just need to move that out. Okay, cool. And we can actually show you this happening by, if I just make this run. So if I go generate, oops, just need to make that static as well. Pass it in null, we can actually see it breaking if we get rid of this guy. No idea what that is, so let's just say no. Okay, so our application is running and we should see it crash into Visual Studio soon, hopefully. Or not. There we go, took a while. Okay, so we've got our null argument exception, which is what we're expecting. Okay, so if we do our null check, and then I'll just put a console.read key so it doesn't quit. That'll prevent the code from crashing because then it's just going to return null. Okay, so that's pretty good. All right, so the feature in C# 6 that can help you avoid doing all these null checks is the null, conditional null operator. So I'm just going to get rid of that. And all we need to do is put in a question mark. Okay, so favorite coffee question mark dot. Okay, so if I run this, I'll get the same behavior as I got before. So if I just press a key, it doesn't crash. Okay, so secret source is in this question mark equals. So what that means is essentially check if favorite coffee is null. If it's not, then proceed with the rest, the stuff that's after the dot. If it is null, then simply return null. Okay, it saves a lot of basically if checking. Okay, so there, the question mark dot. Okay, so like I said, the question mark basically tells it to check if that variable is null. If it is, return null. Otherwise, do the stuff after the dot. Okay, it's very similar to the ternary operator or conditional operator, where basically you had a Boolean statement. For example, has GST. If it does, question mark, do times 1.1. Otherwise, subtotal. So if you're familiar with that ternary operator, you'll quickly get used to the null conditional operator. Okay, and it saves you a lot of lines of null checking. Okay, now what would be better is, well, another case where you would use this a lot is with events. So when you have an event and an event handler and something to help you trigger the event, we have code like the above where we need to check whether there are any subscribers to our event handler. And then if there is, then actually run it and invoke it. So that's a very common pattern. So with this null conditional, we just simplify that down to one line rather than having this if statement all the time. Okay, next up is the name of expression. Okay, so in the previous example, doing this null check probably isn't good because we actually want to know whether we're passing in a null because that's probably an invalid operation. So the correct thing to do would actually be to pass the argument null exception with the parameter name. So if I actually go ahead and do that, so let's reverse that. So I'll throw new argument null exception. And normally what you pass in is the parameter that was null, so fav coffee. Okay, so that's pretty common. If I run the code, we can see it crash with that null exception, which is great. That's what we want. If we see the details, it tells us which parameter. So parameter name fav coffee. Okay, so that's what we want in terms of exception handling. Now, the problem here is what happens if I refactor this guy? Okay, so if I rename this to coffee orders. Okay, you saw all the other variables in code changed, but this string here didn't. It stayed as favorite coffee. So if we still run this, we're going to get an exception that now no longer matches our parameter. Okay, we'll just wait for it to actually kick in. Come on. There we go. Okay, so it's still referring to that old parameter name. So the fix for this is to use the name of method. So you just wrap it around name of, pass it in the parameter. Oops, change that to coffee orders. Oh, that will do, yep. Okay, so this time if I refactor it and rename it to coffee orders 2, or coffee order 2, you can see that that argument is also changing as well. So it's very handy whenever you need to refer to a parameter name in a string. All right, cool. Okay, so as I said, in C#6, we can just use name of the expression. Okay, it gives you compile time checking for the parameter name, which is great. All right, next up is expression-bodied functions and properties. Okay, so quite often we'll have to do like a calculated column on our class. So for example, for the coffee one where we had name and size, the order description would just be name dash size, and we'd do like a read-only property like this. So in C#6, we can simplify that down to a more like lambda-like statement. So let me be lazy and I'll just copy the code and we'll refactor it. Okay, so previously we would be doing something like this to return the format, or we can use our new string interpolation if we want. And go boom, name, oops, capital N, and size, which is better. Or we can just get rid of that altogether. I'll just make that number 2. We use our equals greater than, and actually just make it return what we want. Okay, so that's perfectly valid as well. So it saves us having to put this, I guess, redundant get variable, get accessor. Okay, cool. So that just makes your code a bit neater. Okay, and if you have a look at this code snippet here, if you have a guess of what language this is, it's very similar syntax to what I just showed you, where you basically have your property, the equals arrow, and then whatever it needs to return. That's actually TypeScript. So if whatever you're learning here is also sort of transferable to TypeScript. Okay, very similar. It's great. All right, this one, exception filters. This one's nice and handy as well. If you have to deal with like database calls, normally you put a try catch around the database because it could be all sorts of stuff happening with the database, like a timeout error or a deadlock, or just some sort of foreign key exception, or if you're doing a delete or update. So what you normally do is that you have to check the error code, and then Microsoft has like an MSDN article with literally tens of thousands of error codes. But you pick the one you want, and then you decide how you want to deal with that, whether you retry the logic, or you throw it back onto some queue for retrying, or you report back an error, or log it. So the downside of this is that all the code to handle the different types of errors is stuck in this one catch block in the switch statement, and it just makes the code like hard to read. So with C#6, we've got exception filters where we basically can split up all the errors into different catch blocks, similar to how you would do it if you had for different exception types. So SQL exception, argument null exception, or just the general exception. So the key thing here is that there's a new when keyword you put after the catch. So you do the when, and then you specify whatever the filter is. So in this case, error code equals -2, or error code equals 1205. Okay, so this keeps your code nice and sort of compact, and it sort of packages up nicely so that you can easily debug it. You're not trying to sift through the big switch statement. Okay, so that's a pretty cool feature. Okay, so yeah, nice contained blocks. Hot tip for you, if you want a peaceful weekend, you can do something like this using the filter where you catch the exception if the user is the boss, or if the day of the week is Saturday or Sunday, you can just ignore the error. So you can do stuff like that. Don't do that. All right, and the last one I'll be going through today is static using. So static using is sort of similar to VB, how they've got the with statement, where it sort of just takes that sort of namespace, and you don't have to keep repeating it. So here, for example, if we need to use the math variables like math.py, the static pi, and math.power, so this is obviously to get the area of a circle, but we're repeating that math namespace all the time. Okay, so what we can do is we can say using static, and that just gives you access to all the static properties and methods in that namespace or in that class. Okay, so it just makes it the code nice and clean. So we've just got pi times power. Okay, so no more duplicate static namespaces, cleaner code. You can also use this for stuff like console logging or writing to logs, that sort of stuff. Yeah, like I said, it's like the with statement in VB.NET. Okay, there's a couple more features as well, which I won't be going through, but you can do the await in the catch and finally blocks So just more on the asynchronous programming side of things. And there's some more extensions for collection initializers as well. Okay, so you should start using these features now. If you've got Visual Studio 2015, you've got it out of the box. If you're using Visual Studio 2013, you can install this NuGet package called Microsoft.NET.compilers to get these features. For your build server, you either need to install the build tools, or if you want, you can install Visual Studio 2015 on the build box, or you can also just reference the Microsoft.NET.compilers. Okay, so with all these goodies, you should be 350% more productive at coding, because you're certainly typing a lot less code. But I guess the thing is, I've done a lot of code reviews, I've seen a lot of developers. Most developers aren't using these new features. So if you want to be like proactive and actively get reminded of using these features, ReSharper actually sort of gives you the tooltips to switch to using these. So these are off the ReSharper sort of website, but it gives you all the syntax highlighting for when you can use these new features. So here's an example of using the conditional nulls. Okay, so you can use ReSharper to simplify down that fairly complicated statement into something really nice and concise, like that. Okay, or the string interpolation as well. So you start off with the string.format, you trigger the ReSharper IntelliSense refactoring thing. Okay, and then you can switch it over to use the string interpolation, which we've got there. Okay, so nice and easy. And you get fully IntelliSense for it as well. Okay, cool. So two things. That's my Twitter. If you can tweet out your favorite C#6 feature with the hashtag #DevSuperPowers. You can find my slides here, and obviously check out the other videos at #DevSuperPowers. Thanks.